Hi, Year 11 Mathematics Advanced students. Today we're continuing on with the topic of functions and we're doing properties of functions, which is our third exercise. So we can use the properties of functions, such as their intercepts, to draw their graphs. We have two types of intercepts. The x-intercept of a graph is the value of x where the graph crosses the x-axis. And so to find the x-intercept, we substitute y equals 0 into the function y equals fx. Then we also have the y-intercept of a graph, which is the value of y where the graph crosses the y-axis. So to find the y-intercept, we substitute x equals 0 into the function of y equals fx. For our first example, what we need to do is find the x and the y-intercepts of the function that we have been given, which in our case is fx equals x squared plus 7x minus 8. So it's actually easier to find the y-intercept first, so we're going to do that. So for the y-intercept, we let x equal 0. So when we let x equal 0, we have our fx is actually our y, so we have y equals our 0 squared plus 7 times 0 minus our 8, leaving us with y equals negative 8. Therefore, our y-intercept will equal negative 8. For our x-intercept, it's a little bit trickier as we let y equal 0. So when we let y equal 0 in this case, we'll have 0 equals x squared plus 7x minus 8. So now we have created a quadratic equation. So we need to use our PSF, our product, sum, and factors, to solve this. So our product is our constant, which is minus 8. Our sum is our coefficient of x, which is 7. And our factors are our factors of 8, which is 1 and 8, and 2 and 4. So now we need to work out what factors of 8 add together to get 7, and multiply together to get 8. So in this case, it's going to be 1 and 8. However, we need to make 1 negative, so that 8 minus 1 is 7, and minus 1 times 8 is negative 8. So once we've done this, we can write our double bracket. So we'll have x plus 8 and x minus 1 equals 0. So therefore, x will equal minus 8 and 1, and therefore our x-intercept equals minus 8 and 1. So we have answered our question as we have our y-intercept equals negative 8 and our x-intercept equals negative 8 and 1. Moving on to the domain and range, we have that the domain of a function is a set of all x values, for which fx is defined, so the set of all x values. And then we have our range. So our range of functions y equals fx is the set of all y values. Now when we write what our domain or our range is, we write them in interval notation. So when we talk about interval notation, we have our square brackets, like these ones here, mean including our letters, or including our value. However, our round parenthesis type brackets means excluding. So we can relate this back to when we talk about our inequalities. So when you think about whether a number is included or not. So when we have including a number, an inequality that you might think of is less than or equal to, or greater than or equal to, which is a closed dot. So it means including. And when we have excluding, we have less than or greater than, and it's an open dot. So just to recap, excluding is like less than or greater than, and including is like less than and greater than, but equal to as well. So for our examples, we want to find the domain and range of each function. So when we find the domain and range of a function, we should think about the graph. So for our first one, we have f of x equals x squared. So if we were to draw a quick sketch of an axis off to the side, we have our y and our x. If we were to draw fx equals x squared, we would have a parabola. Okay, this sketch doesn't need to be perfect. So now we want to state our domain and our range. So remember, the domain is what values our x can be. So if we think about our parabola, it's going to just keep on going, keep on going, keep on going. So that means that all x values can be included. So it would be all x values. So when we want all of our real numbers, all of our x values, we use this last one down here. We use our negative infinity to infinity. So our domain is going to be that. So it's going to be negative infinity to infinity. Okay, because it means all x values. Then for our range, it's what y values can it be. So for our range, we just need to remember that our y values that it can be is going to be above the x-axis, because none of our y values below the x-axis are going to work. So it includes the x-axis though, because y equals 0 is a point. So we are going to do a square bracket 0, because that's where it starts, and we're going to go up to infinity because it can be infinite numbers above the the x-axis that our range is going to be. So remember, domain is the x values, range is the y values. So now looking at y equals the square root of x minus 1, what we want to do is we want to find our domain of that, and we want to find our range as well. So if you're not sure what y equals the square root of x minus 1 is, what you can do is you can use Desmos. So that's what we're going to do right now. I'm just going to quickly go to it for you. If I can find it, there it is. Okay, and we're going to put this into Desmos so we can show you, because there'll be some functions that you're not sure what they look like. So we just type our function in here. So you just type y equals the square root of x minus 1, and we get this graph here. Okay, and so for our x values or our domain, you will notice that our x values, it starts at 1, right? That's a 1 there. That's where the graph starts. So our domain is going to be starting at 1. So including 1, so we're going to do a bracket, a square bracket, and then the x values that it goes up to is it just keeps going. So it's going to go up to infinity in this case. Okay, so if I zoomed out, it just keeps going. So our domain is going to be 1 to infinity. Okay, and then our range. So if we go back to our graph, our range is what? So our graph starts on the x-axis, and it goes all the way up. Okay, there's no point that it reaches and it stops. It's just going to keep on going, keep on going. Look, I'm in the 3,000 mark at the moment, and it's just still going up. Okay, so what we're going, it does stay very close, but it keeps going. So what we're going to do is our range for y equals the square root of x minus 1 will be a square bracket 0 to infinity. So you can either draw infinity by doing the 2 circles, or it's just like a figure 8 but on the side. Okay, it's a bit sketchy when I draw it like that. Hopefully you understood all of that. If not, you're more than welcome to ask later on. Next, we're moving on to increasing and decreasing functions. So when you draw a graph, it helps to know whether the function is increasing or decreasing on an interval. So if it is, if a graph is increasing, y increases as x increases, and the graph is moving upwards. So if the graph is increasing, a tangent drawn to that part of the graph will have a positive gradient. So if we draw a tangent to our graphs here, so tangent just means a line that hits our graph, like so, a straight line, a linear function, we'll see that it is going in a positive gradient. If a graph, however, is decreasing, then y decreases as x increases and the curve is moving downwards. So if the graph is decreasing, a tangent will have a negative gradient. So if we go and we draw our tangent, like so, and a tangent like so, you'll see that it's going in a negative direction. It's going downwards, okay, instead of going upwards. So if a part of a graph is neither increasing or decreasing, it is stationary, and the tangent is called a zero gradient. So if we look at our examples, we want to state the domain over which each curve is increasing. What I'm first going to show you is when a graph is stationary. So a graph is stationary when it's at 0. So it'd be when the tangent looks like a straight line, when it looks like a horizontal line. Okay, so that is an example of a stationary. But moving on to our example, we want to state the domain over which each curve is increasing. So our curve is, for our first one, it is decreasing, 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 until it gets to this stationary point, okay? So when it gets stationary, and then, I believe that's the color I use, it starts to increase, 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 increase. So the domain over which this curve is increasing is just this blue bit here. So our domain is going to be from, so we do our square bracket, x2, and it's just going to keep on going up because we have a parabola, so it's going to be to infinity. We do our open bracket. Okay, looking at our next graph. So for B, what we want to do is we want to identify where our curve is increasing. So the curve is increasing on the left of the y-axis when x equals 0. So it's increasing on the left. So we are increasing. We are increasing, increasing, increasing. We get to a stationary point. So that means that we change our direction. So we start decreasing. And then we hit another stationary point and we start increasing. So we're increasing, then we're decreasing, then we're increasing. So the curve is increasing for x1 is less than 0 and x is greater than or equal to 0. So we're going to have two different domains that we're going to write down. So our domain, our first bit of increasing is going to be from negative infinity all the way up to 0, including 0. And then it's going to be from x3 all the way up to infinity. So it's just not going to be between our 0 and where our x3 is. It's not where it's going to be. So however, when we have two domains, I shouldn't have written it like this. When we want to join our domains together, we write it as a union. So we do our union, which is just a U symbol. So this U symbol equals union. And it means that it means end. So it equals the word end. Okay. So then we have our x3 to infinity. So it's like when we're joining two separate parts, and we'll meet this symbol of union again in probability when we see it. Okay, so even and odd functions. We have even functions which have graphs that are symmetrical about the y-axis. So even functions are symmetrical about the y-axis. So that means the left and right halves are mirror images of each other. So a function is even if f(x) equals f of negative x for all values of x in the domain. And then we have odd functions. So odd functions have graphs that have point symmetry about the origin. A graph rotated 180 degrees about the origin gives the original graph. So a function is odd if the function of negative x equals negative the function for all values of x in the domain. So let's have a look at some examples. So we have determined whether the function is even, odd, or neither. So we have fx equals x squared plus 3. Pretty much whenever you see x squared and no other x's or no other pronumerals, you're going to try to check that it's even. So we're going to check. So check even. Okay, so when we check it's even, what we do is we sub in the f of negative fx, and we do this for both. We always sub in the function negative x. So whenever we have x's, we put in the negative. So minus x all squared plus 3. So we know that anything negative squared is just the positive, so it's x plus 3, which equals our function f of x. So because it equals our function f of x, it is an even function. Okay, looking at b, because it has an odd power, so because these powers here are odd, and that would be a 1 if we were looking at it, because we have an odd power, we're going to check odd. So we're going to check for odd. How we check for even, odd, or neither, we do exactly the same. So we sub in negative x wherever we have x's. So we go, the function of negative x is negative x all cubed minus negative x. So anything cubed will stay negative, so it will be negative x. And we have minus negative x will turn into plus x. So then what we do is we, because it doesn't look like our original function, we can cross out that it's not even. So then we try and take a negative out the front. So when we take a negative out the front, we get x cubed minus x when we take a negative out the front. So we keep this cubed here no matter what. Okay, because we know that anything cubed is going to stay a negative number, and we don't know what x is in this case. So because we've taken a negative out the front of our original function of x cubed minus x, we have a negative of our function. So therefore we write odd. For our next example, we want to determine whether it's even, odd, or neither. So generally with this one, what we're going to do is we are going to check it first by subbing in the negative x wherever we have x's. But because we don't know what it's going to be, we would assume, looking at it, because we have our odd powers, and because you have even powers also, you would assume that it's going to be neither, because it could be odd and it could be even. Okay, so I'm going to show you why. So when we sub in a negative, we have 2 times negative x cubed minus 3 times negative x all squared plus 4 times negative x plus 4. So we don't need to write that out again, sorry. So it just equals negative 2x cubed minus 3x squared minus 4x plus 4. So it's not going to be, so it does not equal the original function. So it does not equal f of x, therefore not even. So then can we take something out the front? If we took something out the front, so if we took our negative out the front, we'd have negative of 2x cubed plus 3x squared plus 4x minus 4. So that is not the same. This function here is not the same as what we were first given. So it can't equal negative, the negative of the function. So therefore it's not odd. So as it's not odd or even, it is neither. It's neither function. Looking at D, we have gx equals 2 over x plus 1. We can have another letter here instead of f. So in this case, we have g. So what we're going to do for g is we're going to sub in negative x where we have an x. So it will be 2 over negative x plus 1. Okay, so that just equals 2 over negative x plus 1. So this does not look exactly... So this does not look like our original function. So it's not fx. Therefore, it's not even. So then we're going to try and take a negative out the front. So when we take a negative out the front, to make this 2 positive, we'd have to put a negative in front of the 2. Our x would go to a positive x. But to make this a plus 1, we'd have to have a negative there. And that is not our function. So it's not f of a negative of the function, so therefore it's not odd, so therefore it is neither. So when proving something is even, odd, or neither, you always just make the function, you sub in negative x into the function. If you can make f of x, so if you can make the function back how it was, it's even. Basically, if you have a even power, everything's even power or is constant, but you have to show this. If it's odd, when you sub in negative x for all your x values, you should take a negative outside of the function, and if it doesn't work, neither of these work, it means it's neither. You should now be going on and doing exercise 403 from the Maths in Focus textbook. If you're in extension, or if you're in advanced, you should be doing 303 from the Maths in Focus textbook if you're in advanced. So I will just write that on the screen just in case. So advanced is 303, extension 1 is 403, and that's it.